Welcome to the April meeting of the Houston.net Users Group. You're welcome to join us in person for pizza, prizes, and networking on the second Thursday of every month. Our meetings are hosted by Improving Houston in their office at 10111 Richmond Avenue, just inside the Beltway in Houston's West Chase District. You can check us out for meeting notifications at HDNUG.org, on Facebook, or on LinkedIn. And now, a word from our sponsor, Teals.
If you work in the tech industry, you really should volunteer for Teals, because without your contribution, without your help, there really won't be any other developers.
Whatever field or career that you're in, whether it's teaching or not teaching, it's your responsibility to give back.
There is a time commitment involved in the volunteering process. I think the rewards are definitely worth it.
It's the best part of my day. I would spend more time if I could, to be honest.
You should volunteer with Teals because you have the opportunity to help change a student's life.
Hello, everyone. Hello. Thank you for coming to the third of the tour. No one here made San Francisco then. No one made the special effort to travel 2,000 miles to see me last time. Thank you very much for coming out to see me. I'm always impressed and amazed when people give up their own time to come and hear me speak. It's really nice. I've been speaking now for about 15 years, and when I first started, honestly, it was almost one-to-one consultancy. Now it feels about the same, but it's nice to be able to do it to a larger group. Okay, I just wanted to hammer home the message earlier from Teals, actually. I started my career at school being taught computer science. And my computer science involved, here is a spreadsheet, put numbers in it. And then do an extended 6-week project in this spreadsheet. And then you'll be a computer programmer. And just to give you an idea how important what people here are talking about, I was told that I submitted my work for that particular qualification, and I was told to stop doing it because the professor could no longer understand what I'd done. He told me, you'll get no better than a C because I cannot understand what you've written. I'd written about 20,000 lines of BASIC, and it worked. I don't know how I managed that, but it did.
Working is a feature.
Working was a feature. But yeah, because he couldn't understand it, he would mark it a C.
Because he never even tried
He'd never written BASIC. So anyway, I think it's absolutely crucial that we're teaching these things in school and at home. My daughter is 9 years old and she's a fairly good Python programmer. She's gone straight to Python, mainly because she wanted to code what I coded in at home. And not at work, I was doing Java at work, but I didn't want to inflict pain on her. So yeah, she does Python. And the great thing about that is she can do really little hello world things, and she can do AI. Scary thought for a 9-year-old, but there we go. Okay, so moving into what I was going to talk about normally. This tour has been absolutely amazing. I've been right across the country almost. And I can have to say this, you have an amazing country, amazing group of people that I've met. Everywhere I've gone, everyone's been very friendly. Even though the message I bring is one of chaos. They're still very warm and welcoming, which is good. But you have chaos because you've got Zuckerberg. So first of all, why am I doing this? The bit of background as to why I'm even doing this at all. About a year ago, almost exactly a year ago, I was sitting down with a bunch of conference organisers. And I'd just done my talk, and it was the evening, and it was a speaker's dinner. And anyone here been to a speaker's dinner before? Okay, so there's usually reasonably large amounts of wine involved and beer. And we were at the point in the evening that I like to call whiskey o'clock. And so I was fairly into the hour of whiskey o'clock. And one of the organisers turned around and said, well, how could we make this conference cooler and more interesting? And so apparently, I don't remember this, but apparently I put my hand up and said, what you need to do is you need to be able to spend some money and send someone across the US on a motorbike telling everyone the message of this conference. And then I promptly forgot all about it. About a month later, when the hangover had gone just, I got a phone call where they said, Yeah. All right, well, do your idea. Took me a little while to remember what that idea was. But then I realised, and I thought that'll be good, I'll do Route 66, nice shortish journey. No, I'm not even doing that. Someone then said, why don't you do Atlanta? Now, I'm no genius when it comes to geography, but Atlanta was never on Route 66 that I ever looked at. But it is on my route, so that's why I'm doing this crazy thing at the moment. And I thought, what's the most interesting thing I could talk about? Something that's super relevant to almost every system we work on at the moment. And for me, at the moment, I could talk about microservices. I could talk about cloud-native systems. I will talk a little bit about both those things, but the thing that joins them all up is chaos engineering. And I also like it because it's one of the most misunderstood parts of the whole game. Anyway, this is the conference that's happening when I get there. They're not starting without me. At least they say they won't. And there is a 20% off the tickets there to go. Now, why should you go? First of all, the tracks are awesome. Well, actually, one track is awesome. This one, because I organised it. All the tracks are awesome on this. And the fun thing about this conference is all the speakers hang out with you. It's a very good community feel to these conferences. So if you do fancy a trip up north, then you can get your 20% off and go and see it. And if I can't entice you with that alone, if you think I look a little bit shabby now, and I know I do, imagine how I'll look at the end of the tour. From a sheer curiosity point of view, you must want to see how bad that can be.
When do you get to Atlanta?
Atlanta is on Tuesday next week. I've got a bit of a break over the weekend. I've got New Orleans.
Tuesday next week I might meet you there.
Oh, perfect. We'll do it. It'll be the same again. But, but yeah, there'll be more T-shirts.
And you'll be a bit more rough around the edges.
I'll be much more rough around the edges. I've done New Orleans.
Where's the conference at Chicago?
Where's
the conference at Chicago?
Where is it at? Oh, that's an excellent question.
It's a big city.
It's a big conference, and I don't know where it is. I'll check that data for you.
No, I'm just curious.
It's in a hotel somewhere. I know the hotel-ish. I'll put it in my sat-nav. Anyway, I'll find out. I'm a speaker. They drive me there usually.
It's downtown. There's a lot of neat places down.
Oh, I think it is downtown. We've been to a few neat places, so I assume it's...
Isn't it in the title slide?
Well, that one.
It's the market. It's in the group discount Chicago. Like in the group discount.
Sorry. I'll find out for you. But it's there. You can use the discount. Oh, by the way, it used to be Geek 10 was the discount. I don't know if I've still got that slide in there. Yeah, it used to be Geek 10. I have tried it with all different numbers to see if I can get a bigger and bigger discount. It doesn't work. But just in case you were feeling a little chaos engineering after this, yeah, it doesn't work. I tried. Okay, so who am I? I am Russ Miles. I live and exist on Twitter. I apologise for that. I have no other personality. I have no other life.
You could be president.
I wasn't going to say it. But I'm trying to out-tweet it. We have nothing in common, but I'm going to put more tweets out there. Yeah, so I should like certain individuals, I tend to binge tweet. So follow me briefly if you're on Twitter. And then if you get bored, I will take no offense if you walk away from me. Because I tend to do no tweets for about a day or two, and then I completely fill up the timeline with inane thoughts that I have. Sometimes they're useful, most of the time not. But yeah, follow me on there. That's where I put most of the information about the different courses I'm doing, the different talks I'm doing, everything I've been involved in. Including this tour, and it's now Geek 20. In fact, it's Geek Tour 20, just to make it more confusing. That's the one to use, to get yourself some money off. No one asked me what 20% is of the, I don't know what the price is, so yeah, you have to work that out for yourselves. Okay, so what am I doing? Yeah, what am I doing at the moment? I am big on open source. I do an awful lot of open source work. And this is my latest project, the Chaos Toolkit. It's a free open source toolkit for doing chaos engineering. If you don't yet know what that is, or if you only suspect what it is, I'm going to hopefully explain it in some detail over the course of this talk. And I'm going to show you how to do one facet of chaos engineering with this tool. If you are interested in what's going on in the tour, I'm writing a book. I had this thing of, I'm doing 5,500 miles. How can I make it more difficult for myself? apparently, if you write a book as you're doing it, that makes it significantly more difficult. So I'm writing a book as I go, publishing it as I go on LeanPub. Now it's free. You can go grab it. It's on LeanPub. But if you have ethics, then you could donate. What? You could donate. Yeah, what's this thing? If you don't know what ethics are, then don't worry. Your life will be very pleasant. But if you have ethics, then you can donate. And there is a small amount that goes to LeanPub. The rest of it goes straight to Girls Who Code. So I'm not taking any money from it, but I'm writing it for fun as I go. And anything I talk about on the tour is going into that as well. So if I talk about a technical subject, it goes in as well, because why not? Okay. So why do we even have chaos engineering? And why are people starting to get excited about doing chaos engineering? And essentially, why chaos? Okay. First of all, before we get into the subject matter, I have a confession. I hate the title, chaos engineering. There's one thing we could do in this industry. It's stop naming things. We are awful at it. We took a fascinating renaissance in data persistence and access technologies, and we called it by what it isn't. We called it NoSQL. Worse than that, it's not what it's not. So let's, I could go on. Microservices. We have to worry about the size of them now. No, that's not the point. And it's worse, chaos engineering. Whenever you say chaos engineering to people, the first thing they hear is, you're going to destroy stuff, aren't you?
I hear Jeff Goldblum.
Your Jurassic Park just comes flooding back in.
I hear Maxwell Smart.
Well, yeah, I was saying the same thing. It's smart.
It's.
You get the old, remember that.
It's none of those things. It's engineering yourself out of chaos. Is my personal definition of what it's about.
So you call it chaos reverse engineering.
It would be great. No, round trip. And no, I'm not going to. So I'm old enough to be in the industry to go round trip engineering. What a ridiculous idea that was. This idea we could draw things and then generate code, and then the code would then come back into the drawing, and it would just all work. And it never did. I spent many years of my life working with rational rows diagrams.
I'm sorry.
Oh, please. Everyone should just apologise for the whole existence of it. I was an early adopter of rational rows. Yes. I wrote a book on UML. I'm sorry. We all do crazy things for money in our youth. Okay.
It was quite irrational, I thought.
It was totally irrational. Actually, a little hint. If you're going to write a book, don't put the most important message in the preface. No one reads it. I put in that preface, use UML to do sketches to communicate with people. And I still get people emailing me going, which tool would you recommend for doing UML? And they get upset when I say a pen. Anyway. So, the reason we have chaos engineering is that our systems are becoming harder to trust. And I don't mean necessarily in the secure sense or the data security sense. I know it's topical right now. I mean in the sense of just knowing what they're doing, believing in them, being able to trust that they're going to be available, being able to trust the fact it's not going to wake you up at 6 a.m. on a Sunday. Things like that. Building that trust back in. The fact is our systems are getting more complex, and the pressure on them is increasing for them to change more frequently. That was actually the reason we did microservices, was to be able to evolve the systems faster. But when you do that, you generate a problem for yourself. And that's what chaos engineering is trying to help us with. And the problem that we end up with is that production hates us. And I don't mean it in a passive sense. It hates you. It knows your name. It knows when you're asleep. It's a bit like Santa Claus, but not as bad. It knows when you're out for a romantic meal. This thing is evil and hates you. And so one of the things I want you to adopt out of this talk this evening is a different mindset towards production. Production is a hate-filled, horrible place for your code to be dropped. Okay, so one of the mindset changes I want you to get into the mode of here is I want you to think like a motorcyclist. That's the only link I could possibly think of to what I'm doing. Okay, but this is true, right? So who here drives a car? I imagine in Texas, I'm kind of okay with that one. Most people drive a car, okay, or you know someone who does, right? So if you drive a car, when you're taught to drive a car, assuming you'll drive legally, when you're taught to drive a car, you're taught usually that everyone else cannot see you. So drive like they can't see you, right? On a motorcycle, we're not taught that. We're taught they can see us and they want us dead. It's not paranoia if it's true. I've driven through this today. I know they want me dead. Yeah, we stay alive longer that way because we treat the road as a hostile environment. Not just the other road users like drivers. We treat everything, the weather, the little dog with a little old lady beside the road. They want me dead too. And when you think that way, you treat that environment very differently. You're dropping yourself in a hostile environment. You lose all arrogance and you have to deal with it with that thought process. It's different. Production is like that for your code. It is not where your code works. It is the environment where your code is most likely not to work. Okay, so production hates us. But why does it hate us? What have we done to cause it? I mean, we never used to say this. We used to say production loves us. Or back in development, back in the day, I used to say, what's production? I don't care. I got QA for that. The last I see in my code, it's written. I'm out of here. Yeah, so why do we have this problem now? Okay, so this is a way of categorizing systems, I suppose, called Kinevin. I won't ask you to look it up if you haven't seen it before because it's not spelt like it sounds. It's actually spelt like Cynefin. C-Y-N-E-F-I-N. It's a Welsh word, sorry. Now, I'm going to abuse it a little bit because I want us to realize the nature of the problem we've created for ourselves and why it's a good thing. Number one, you're not down here. The systems you create are probably not simple. Unless you are paid to create Hello World. And if you are, well done. You will live a long life. If you aren't doing that, then you're not in Simple. The problem is Simple's really attractive because there are best practices down here. I can go to you, just do this, and it will be better. Do this thing, you'll be much better for it. So it's attractive to be down there, but we're not there. You probably think you're up here in complicated. You probably think the systems you're building are complicated enough, but we're dealing with it a little bit. Every now and then we have a bad experience, but it's always okay. And this is attractive as well because we have good practices. Someone like me can come along and go, do this, you'll probably be better. Try it out. You'll probably improve if you do this. Now, the difficult thing is, you're probably not there either. Because when you factor in not just the production system, but everything that surrounds it, the people, the processes, the tools, everything, you'd be hard pressed to say you're in just complicated. And if you've done anything that you would notionally label as microservices, please, I can talk about what microservices are or are not over a beer. It will take a beer and we'll get through it. But whatever you label these things as, if you're doing something microservice or working to the constraints of cloud native, then you're at least in complex. By adding people in the socio-technical system of software delivery, you are in complex. Complex is a little more difficult to deal with. If you try and drop a best practice into complex, it will likely fail. You see this all the time with naive agile coaches. They come in and go, just do this, you'll be a lot better. And then everyone goes, wow, this is horrific. Ah! And then they do it. And then after about 3 weeks after the coach has gone, everything goes back to normal. There's a reason for this. The system is complex. The simple answers don't work. Okay, with a complex environment, you have to probe it. You have to work with it. You have to respond to it. You have to use the consultant's answer. It depends. You also have to look for what emerges from it. It's not a bad environment. It's recognizing the nature of the beast. And we look for what comes out of it and how we can then use that to make better for us. But you're not there. Because if you're doing cloud native microservices, or even if you're just doing systems that change very frequently, which was the point of doing all the stuff in the first place, then you are trying to adapt to change frequently, which means you are in chaotic. As soon as we throw the stress of change onto your system, which is why we did it all like this in the first place, you end up in chaos. The problem with chaos is we're looking for surprising answers. There are no best practices. There's no just go do this. We've got stuff that is going to appear to us in here. It's not the best of places to be. So guess what we need? We need a technique that engineers us out of chaos into the merely complex. That's chaos engineering. Okay, so why is it so chaotic? Well, it turns out that there are lots of ways that our confidence and trust in these systems is being attacked in the nature of the system. You're probably familiar with some of the chaos engineering tools out there, things like Chaos Monkey. Okay, you probably heard of Chaos Monkey. You may have heard of Chaos Kong. I'm still waiting for Chaos Caesar, evolved Kong. Anyway, that was mentioned to me last night. So Chaos Caesar's got me next. I'm like, yes. These tools work at the infrastructure level, and it's easy to assume that's the only place that chaos happens. Now, it is a place that chaos does happen. Bear in mind, production hates us. And in production, the networks hate us, the machines hate us, the virtual machines really hate us, and the operating systems are not our friends. Okay, so given all of that potential for failure, this makes a lot of sense. But it's not where it finishes. Most people, when they see those tools, they think that's all chaos is. It's far from it. Because we've also got the platform. Maybe you're using Azure. Maybe you're using some platform of your own making. Maybe you're using Kubernetes, which, by the way, in the container world is just winning. If you're not using Kubernetes, you should be, if you're using containers. But those platforms also fail. One of the things that I've seen recently is that Microsoft have now announced a Chaos API for Azure. I love that idea. That's really forward thinking. They're saying to you, you cause chaos against your own systems to prove that our system and your system can actually handle these sorts of things happening. It's very sensible. But that's all at the platform level. You're not really interoperating with their underlying networks, but you are starting to play with how their containers and services work. Applications, the stuff we write, causes chaos. Your latest release may cause chaos. You drop it in, everything looks fine. 7 days later, you realize it was wrong. And there's a problem because rolling back is difficult 7 days later. So that's another set of chaos that we want to explore. Now, these are all technical areas of exploration. My favorite area is the last one. And it's the biggest cause of system failure ever. Us. It's always us. This is where the horrible phrase of pilot error comes in. Okay, if you've read anything by Sidney Dekker, hopefully your mindset will be slightly different from the let's blame the pilot. Actually, I talked about chaos engineering in Oslo just before I came on this tour. And a gentleman, I said to the room, can you tell me about your production failures? And a gentleman got up and he said, and full respect to this man, full respect. He got up and said, it's my fault. I did it. And he said what he'd done was he'd destroyed a high-performance computing cluster for all of their customers. And he had done it with a command line that had a 1-character difference from the command line that he really wanted to run. He used a G when he didn't want to use G. So instead of taking down a simple admin node, he took down the master node, and the only time they knew was when the customers phoned up and said, why are my jobs taking so long? Destroyed several weeks of work. Fantastic. So people are in the mix. Oh yeah, in that story, the person's not the issue. The system is the problem. We need to improve the system so that if someone does that, when someone does that, we have strategies for that. Sometimes they're technical, sometimes they are process. So this is where, for me, the most exciting stuff in chaos engineering happens. It's when the people are involved. Okay, so how do you get started with it? I disagree with Einstein. My German's really ropey at best, but I think roughly speaking, it's saying there that any idiot can handle simple stuff. It takes a genius to handle chaos. No, it doesn't, thankfully. It takes a mindset, a process, some ethics, there's an ethic again, some practices, some tools, and for me, a minimum bar. Okay, let's run through these things. Mindset. We've already started to introduce the mindset. I want you to think like a motorcyclist when dealing with your systems. But we go further than that. I want you to think in terms of anti-fragile. You see, I worked with a team not that long ago where they said, we're going to introduce all of these gates before production. We're going to do this testing, then that testing, that testing, that testing, that. And then it goes into production and it will just work. We need to make sure it always works in production. And I watched the senior architect in the room. And he sat there, his body language was perfect. It was this. And all I heard was, no it doesn't. It never works in production. And this was a shock to the team. They were doing all this stuff and they assumed it would be fine when it got there. And his point was, you can do some of this stuff, but don't kid yourself. When it gets there, that's where it doesn't work. There is nothing like the conditions you hit in production. It's staging. So anti-fragility suggests that we can build systems differently that can handle this. So you're probably familiar with fragile systems. You may have just seen one with a number generator, sorry. My fault. I'll give you a better example. I'll give you a better example. That's just cruel.
No, my fault.
The other great example of a fragile system is if you're about to do a keynote talk, or if you haven't done any keynote talks, imagine you're doing a big talk to your bosses, and your computer decides to do a reboot operating system upgrade 5 minutes before.
And it always does.
And you're sitting there going, please come back. Please come back. That's what fragile feels like.
That is why you sacrifice chickens.
I saw that happen to Bill Gates right here in Houston.
Oh, it happens to us all. Absolutely. I did when I first played guitar on stage. I did it at the QE2 Centre. I did it as part of a talk. I started to talk with guitar. That morning, I turned up to do my sound check. Open up my laptop. The Mac equivalent of a blue screen of death. I thought this is what we call Murphy's Law, or Sod's Law if you're in the UK. Okay, so that happens, right? Fragile systems. Fragile systems, in the face of stresses like change, fall over and die. We don't usually aim for fragile systems. We think that the opposite is robust and resilient. So we aim for those. The problem with blanket robustness and resilience is it doesn't exist. In order to make a system 100% robust and resilient, do you know what you have to not do to it? You can never change it. You have to seal it off in a bubble and never touch it. As soon as that system experiences change, it will begin to have the potential to fail. So the problem is that we want our businesses, usually want these systems to evolve quickly. That's what we think we bought by doing all these things like microservices and agile, etc. And now we're saying, actually, the more you do of that, the more chance it's not robust and resilient anymore. So the argument here, it sounds slightly counterintuitive, is don't aim for robustness and resilience on its own, because it comes at a cost. At best, it will ignore change. At worst, it will fall over, it will actively resist it. Okay, the good news is, there is an alternative. There is a true opposite of fragile, which is the anti-fragile systems. An anti-fragile system doesn't fall over in the face of stresses like change, doesn't resist those forces. It thrives on them. There's one thing an anti-fragile system needs. It needs to be able to learn. I don't mean ML here, I'm not talking about scary robots. I just mean that there has to be learning loops where the system can adapt and change to what it sees. Not necessarily at live time, people can be in the loop. It can be a design thing. It usually is. Okay. Chaos engineering is about those learning loops. It's about helping us get to an anti-fragile system. Because there are things we don't know. When production fails, it is not usually because of something we knew would happen. It is happening as a surprise. And sometimes it's a catastrophic surprise. And usually it's preceded by someone saying, that could never happen. I've lost count of the number of times I've heard someone say about the cloud, that can't happen. And I sit there and go, right, I'll wait. Any minute now. S3 can't go down.
But it did.
Of course it did. Anything can. That's the fallacy of robust and resilient systems. It's not. A region of Amazon can't go down. I won't go on it. I feel like I'm picking on Amazon now.
A region of Azure can't go down.
Regions that everything can go
Everything
down.
goes down.
Okay. The trick is how we deal with those surprises. Anti-fragile thinking tells us that we have a method for dealing with this. We shouldn't just avoid these things. We should make them happen. We should preempt the apocalypse. We do that because we have second-order ignorance. The way of dealing with second-order ignorance, the things we don't know, is to introduce learning loops. And I mean double loop learning here. Single loop learning is kind of like testing, what we call testing. When you're doing a test, you've got a strategy, you validate or verify that strategy. Double loop learning says that we need to assess the strategy itself. That may be wrong. Our initial strategy and assumptions could be wrong. So we're winging it back to test those things too. That's key when we don't know what we're looking for. When we have to adjust the strategy as we go. That's why I don't call, now people call chaos engineering chaos testing sometimes. Now I should point out that they both exist inside the blanket of what is chaos engineering. But I think there's two things happening in chaos engineering. There's chaos experiments, where we're doing double loop learning, we're exploring, we're discovering, we're finding weaknesses, we're finding what we don't know. And then there is chaos testing, which is for the circumstances where we have found a weakness, we've overcome it, we're going to keep doing those experiments just to make sure it doesn't come back. Okay. So, in terms of a process of how you do chaos engineering, I'm going to show you a process now, and I'm going to show you why I don't like it. Okay, it's loosely following the scientific process. The first thing I'd like to point out, though, is I know quite a few scientists. I did my master's at Oxford University, I'm very proud of it. And one of the things I bumped into was a lot of people doing science and research. And they would giggle when they saw this, because they don't start with a hypothesis. Most scientists, when they're being honest, will tell you they start by prodding it and being surprised. Even if they're working with a theorem, even if they're working with some biology, even when they're trying to figure out how AI works, prod it and something surprising happens. And then they form a hypothesis and they come back to it and prod it properly in a more diligent way with a control group, etc. So this is what it would look like in an ideal circumstance, but for you, when you do chaos engineering, don't think you have to start with a hypothesis. Most people start by trying something and going, whoa, that doesn't look good. And then they step back to a hypothesis. Okay, a hypothesis in chaos engineering is quite specific. It defines what normal looks like. Now that might sound trivial, but when you think about a system, like one of our complex production systems, and the fact that it's constantly changing, what does normal even look like in that environment? But that's what you need to characterize as what we call your steady state hypothesis. That's what you can recognize within certain tolerances as it's okay, acceptable. The second point is more than crucial. Chaos engineering is not about hurting systems in a surprising way. If you end up being somebody like, I got a few phone calls from people who've done this, where they said, we ran some chaos experiments, the teams got really upset. They destroyed all of their production systems, and they didn't see the benefit of learning from that. So here's the trick. If you are doing chaos engineering, and you're just hurting systems, and people are complaining, you're not a chaos engineer. You're a sadist. So as a chaos engineer, what you do is you don't start hurting systems until you've spoken to the people responsible for those systems and find out what worries them. You're exploring their worries, not just your own. Okay, so you communicate to everybody. Everyone knows that chaos is happening. It's not a surprise, doesn't turn up and go, woohoo, everything's gone. Doesn't do that. Okay, everyone knows it's coming. In fact, systems improve if you just turn around and say chaos is coming. Plus you get to say it in a Game of Thrones sort of voice. It works really well. Okay, then you run your experiments. You run it against the system. And you find weaknesses. A good experiment, a successful chaos experiment, finds things. This is why it's different from testing. A good test passes. A good chaos experiment shows you all the failures. Okay? It's a true experiment in that regard. You might set up control groups as well so you can do comparisons. The idea is to discover weaknesses before your customers do. Analysing the results with everyone involved, and then, this is an interesting one, increasing the scope. That implies that we started small, and I would suggest you do. Don't be the person that phoned me up and said, we did Chaos Monkey in production, and it killed everything. We knew it would. Why did you do it then? That's another rule. What comes up in a minute as a rule of Chaos Club. Don't do an experiment if you know it will destroy the system. You already have the learning. Otherwise you're just validating your evil tendencies. Okay, so you start tiny. You kill a pod, or you kill a service, or you kill a container, or you kill a network connection, or you constrict a network connection, or you change the memory consumption profile. Start tiny, see what happens. You'll find enough that way. Okay, you can even start by just talking to people about it, and you can find weaknesses doing just that. We'll talk about that in a bit. Eventually though, once you've overcome that weakness, you might increase the scope. You might eventually start doing these things in production. Some people, well, most people don't start in production. Some people never get there. You can learn from staging. The difficulty with learning in staging that there's a weakness is it's easy to ignore. In production, everyone can hear you scream. In staging, everyone's ignoring you. So you can say there's a weakness here, probably in production as well, but that's the difficulties people will ignore, probably. Okay, eventually you can increase the scope. Now, the last one's important. Everything there could be manual, people doing this. Only when it's too expensive to keep getting people to do it do you worry about the last one, which is automating it. We're going to look at automating experiments a little bit later with Chaos Talk here. But that's for when you've probably got to the point where you've got a really useful experiment that is too expensive to run every 10 minutes because we can't afford the people. Okay, ethics. This is a relatively new chapter. And this came out of an argument on Twitter. I love Twitter arguments. This was a real beefy argument too. What was happening, I love arguments by the way, my background is in psychology. I've had a very interesting career. And in psychology, you're taught in an argument to detect a certain style of argument. When people are working from their different ladders of inference. When you detect this, you can see it, it's when both parties are right. But they're still arguing with each other. neither of them are wrong, but they just don't realise they're talking about different things. So this is what was happening on Twitter. I had one group who was saying, you need a chaos engineering department. Can't do it without it. You need a separate perspective on the system.
Or budget this item itself.
And then I had another group saying, we can't do that. We've got 5 people. My chaos engineering department, at the very least, would be a person. And that would be too expensive for me.
2 hours a day.
Exactly, yeah. So it wouldn't work. And they were saying, well, actually, it's better if everyone does chaos engineering. Everyone thinks this way would be better. And so I'm sitting there going, you're both right. And what I do whenever I see both groups arguing this way is I look for where there's a common ground. And it turns out it was in the ethics. So they're both correct. But there is something that in both of those scenarios, both groups have to have. Otherwise, chaos engineering fails. Without fail, it will fail. This next slide is the most important one I have. I don't care who is doing the chaos, but they have to take a portion of the pain. If you are going to destroy parts of a system to learn about the weaknesses in it, you must be part of the improvement. You must be part of the process of dedicating yourself to the groups, if you're not in the groups themselves, that are going to make this something you cope with. Otherwise, you're back to being a sadist. So I don't care if you set up a separate department. There is value in doing it. They do have separate perspectives. It does make sense. But if you can't afford it, or it just doesn't work for your group or your environment, fine. As long as whoever's doing the chaos feels the pain of the chaos and helps the system improve. The key personality characteristic of a chaos engineer is empathy. Okay, so back to practices. How do we do this? There are 2 main key practices in chaos engineering. It's relatively straightforward in that regard. Number 1, game days. Number 2, automated chaos experiments. Game days are my favourite technique in the world. But that's because I'm a proper geek. Now, as a proper geek, I've played Dungeons and Dragons. And I was a games master. And so as a games master, if you're not familiar with this, if you've had a life, as a games master, you sit there and you set up a scenario. And you put a bunch of characters in it that people have created, and you see what happens. And you build a story around this. It's great fun. That's what a game day is. It's Dungeons and Dragons for production. What you do is you get a collection of people together, you ask them what worries them about production, and you say, right, next week, you're going to make that happen. Or make something like that happen, and you're going to find a way of building the confidence that you can fix it. It's brilliant fun. It also overcomes silos. If you aren't lucky enough to work in an organisation that does DevOps, in other words, dev and ops working together closely, you have to get closer together to do game days. So even if it's only for a few hours, you get to feel the pain of production as a developer. It's also wonderful the amount of weaknesses you detect doing this. Okay, number 1 lesson that I've seen recently, I got asked, how do I make developers write good logging? Easy. Make them the consumer of the logging. Put them in a game day scenario where they have to figure out what the heck their thing's doing. They will write better logging after that. That will come out real quick. And there are a whole bunch of others. I mean, I used to struggle to teach people circuit breakers. Because you'd say, you need to put a circuit breaker in this. You can't trust the dependency you're working with. And they go, yeah. Sure, I get it. And they go, and they ignore it. In a game day, you show them why they need a circuit breaker. All they see is a cascading failure right through to the front end. It's not even technical. One of the things you can look at in a game day is how people work. So you probably are familiar with playbooks in production, where something goes bad, here's like the recipe to deal with it. I noticed at one company I went to that their playbooks were in a room that was locked with a key that could be removed. So we did a game day on staging, and I took the key. I had to stop them breaking the door down. It's amazing how worried they got. Even though they know it's in staging, boy, the pride's on the line, they get very passionate. So we learned don't put the playbooks in the locked room. You know, or if you do, make sure there are 2 keys. Little things like that. So you can attack any weakness in the system. It's the whole socio-technical system. That's what chaos engineering is about. Okay. Automated chaos experiments, as I said, are the things where we've explored something technically and we just can't do this over and over again with the people all the time. It's too expensive. So we'll automate it and take that headache away from ourselves. Okay, I mentioned a minimum bar. Now, you've probably noticed I'm not the tallest human being. When I go to a theme park, there's always that little thing, that worrying little line in the distance that says, you need to be this high to go on this ride. And the older I get, the more nervous I get as I walk towards it, as it gets higher and higher. And one day I know I'm going to have to be like, right, Marley, on you go. It's my daughter. Marley, on you go, Daddy's too short. It's going to happen. That's what I mean by a minimum bar. There is a minimum bar to doing chaos engineering. But it comes with a caveat. I'll explain that in just a moment. So the minimum bar for me is the system needs to have a decent level of observability. I don't mean management and monitoring. Management and monitoring systems are built to answer a question, a closed set of questions. Observability is about giving you a system that allows you to ask open questions, to be able to explore. You can't anticipate the questions people want to ask. So observability is crucial when you don't know what people are going to be looking for. The reason I put a caveat on this is that chaos engineering is a wonderful way of getting people to introduce observability if it's not there. I've seen this a few times. You do a game day and no one can figure out what's going on in production. No one can ask any questions, no one can answer anything, it's confusion. They immediately start to go, oh, we need better logging then. We need better this, we need better that, we need better systems to navigate these logs. That's them introducing better observability because they realise they are in a very weak state. So what I would say is doing advanced chaos engineering requires good observability, but doing early stage chaos engineering actually highlights the fact you haven't got it. Okay, because you have to ask these open questions to explore the system. You can't anticipate beforehand what people are going to want to know. There's a couple of tools I've used in this space, and this is one of them, Humio. Humio is a log aggregation tool. It's used by Uber, amongst other people. Don't judge its ethics on that. Fantastic system. The reason I like it is because in the middle of a chaos experiment, you can actually inspect the logs whilst they're flying past. So you can do nice inquiries and dashboards against live stream logs, which is nice. Another system I've used recently is Weave Cloud. The reason I highlight Weave Cloud is because it gives me a stream of events that are related to who has changed what in production. One of the open sort of questions that you are likely to want to ask when trying to navigate a game day or a chaos experiment is who did what? Weave Cloud, sorry, Weaveworks is the company. This is an article that we wrote on it. So Weave Cloud will tell me who did what when. It does a bunch of other things as well, but that for me is extremely helpful. Okay. So say that you like what you see with chaos engineering. Let me tell you why you will fail to take it back to your company. First rule, when you go back to talk to anyone non-technical, and I call this chaos engineering for the business, the first thing you should never do is mention the words chaos engineering. Drop the term. Don't be afraid to. Let me give you a new one. When you're talking to the MD of the company, or the CEO, whatever you want to call them, and you say to them, we're going to do chaos engineering, and they say, you're not. You've lost. What you should have said is, we're going to do continuous, limited scope disaster recovery. It's exactly the same thing, but that gets a budget. That doesn't get you turfed out the office. Okay? Again, don't forget that chaos engineering sounds like you're going to go and break things. This came out of me working with banks in London. If you go to a bank and say, we're going to do chaos engineering, they go, no. We did that in 2008, didn't go well for us. But if you go, we're going to do continuous, limited scope, disaster recovery, they go, we do something like that already. We do disaster recovery. This sounds good. How much money do you need? No, we can't afford that. And then, yeah, works from there. It works. It's also very, very true. This sort of idea of disaster recovery is close to what chaos engineering is all about. Disaster recovery in most systems is exercised very infrequently. I actually asked this of an audience in November. I asked the whole room, who here does disaster recovery every month? And a few people put their hands up. And I said, keep your hands up if you run it every week. 2 people get their hands up. I said, who here's run it in the last 2 days? 1 person get their hand up. And I said, who here ran it on purpose in the last 2 days? The hand went down. And actually, when you explore it, most people only exercise disaster recovery when there's a disaster. Which is the worst time to learn there's a weakness in it. So we do chaos engineering, continuous limited scope disaster recovery, to constantly get better at dealing with these disasters that are going to happen. The other thing to talk about with people is not just about hurting the system. If you go to someone and say, what do you want to play with or destroy on your system, they'll go, well, we don't want to do any of that. We've just spent our lives putting it together. Why would you want to tear it down? But if you ask them what worries them, what keeps you up at night about the system? What has happened recently? One of the problems you can have with chaos engineering is if you run a chaos engineering experiment that's really wacky, like completely out there, then you know what happens? No one listens to it. Because they sit there and go, that can't ever happen. What you have to do is take something real and maybe go a tiny bit extreme on it. Vary the real world events, and then people will listen. So yeah, talk about production incidents. That's what it's all about. Okay, so some rules of Chaos Club, some little tidbits I've learned as I've been doing this. Rule number 1, it's not about hurting systems, it's about learning. We're learning the weaknesses in our system and we're getting better at dealing with them. That's what we're doing. We're not just destroying stuff. Number 2, chaos is never a surprise. Everyone knows it's coming. Everyone's been part of designing for it, waiting for it, being aware of it. You may be able to tell people months in advance that chaos is coming. Number 3, this is more contentious. If you already know there'll be a failure, don't do the chaos. Now, because I have actually people argue against this. One person in particular turned around and said, I would still want to do it. I would know that if I ran this chaos, it would destroy part of the system. But I want to know what else it might destroy. Which is a fair point. But I'm more of a fan of let's fix the stuff we know and then explore the stuff we don't know. Please.
I would actually argue that there is a time where you know the consequences, you still want to do the experiment because you need to prove it to a higher up in order to make the point.
And,
Yeah.
and you need to prove the recovery too.
What's that?
And you need to prove the recovery too.
And you need, right, but there's always that challenge, and you've reiterated on this multiple times. Well, that can't ever happen.
Yeah.
Well, anybody who's been in this industry for any amount of time knows that's bullshit.
Yeah. So let me extend that further because you're absolutely right. Okay. So the idea that not everyone has the same perspective on there being a weakness or not. Proving it, absolutely. The other thing to do is I don't know if you're like some of the agile groups I've worked with where they have technical backlog items, where they put these up and everyone ignores them, and no one wants to prioritize them, right? That's just the developers whinging again. We don't worry about that one. Let's keep the feature velocity up. Now, nothing increases the sensitivity to a technical backlog item than it coming from a chaos engineering session. Because the non-technical, sorry?
Is that a technical backlog?
Technical backlog item. It's where someone says, we've got a problem, we need to fix it, but it's not really feature related. So most people in the business go, yeah, that's not going to deliver anything, so we'll worry about these things instead. What you can do is you can make people take notice of these technical backlog items if they come out of a game day or a chaos engineering session. If they come out of a game day, you have to have the non-technical stakeholders there. They see them. They see that their system has a weakness, and they can see how it will be a problem for them. So that it makes them understand these things are valuable.
I mean, game day is the day you run the experiment.
Game day actually is usually 2 or 3 hours. Okay, it's get everyone together, make a problem happen in staging usually, and see how everyone deals.
That's the experiment.
It's a loose form of experiment. An automated chaos experiment is usually done as an automated system that will cause a failure to happen either in staging or production, and then the system will react or not. So they are very similar, but a game day is kind of pre-exists from chaos engineering. It was just a technique that came out of an availability group usually. Okay, some tools to get started with chaos. Number one, there are loads of tutorials and training techniques out there on the web. I do training myself. I go all over the planet and teach people how to do chaos engineering. I have a 1-day, 2-day, and 3-day variant of courses. It's usually great fun. I actually prefer to come and facilitate game days because I actually find there's usually a lot more value in doing that. Doing it is better than just teaching it. Okay, as well as that stuff though, before chaos engineering existed,
How many shades of grey are in that picture?
I do not know. Quite a few. More than 50.
256.
256. I'll check the format. Right, so the reason I bring this slide up is I've been teaching chaos engineering for a very long time, but I didn't call it chaos engineering because at the time the term didn't exist. I've been teaching people microservices, and the problem with teaching people microservices is I have to teach them things like service discovery, circuit breakers, cloud native concerns, all that good stuff. And you know what? No one cares about that. That's all non-functional. So what I used to do was I would set up conditions that would cause people to need it. So I would start destroying their services on the course. And then they would see, oh yeah, we need to put something in there that detects that service is gone because we can't trust it being there. Yeah, we call that a circuit breaker. Now we'll have to learn about it. Okay, I used to do this on the last day of the course. I used to call it the 50 Shades of Microservices Day because we're harming the system to make it better. Now, I have never read the book. I promise you, I've never read the book. And I have certainly never seen the films, but I think that's what they're about. Anyway, okay, but apparently this wasn't the sort of title that Amazon wanted for their tutorials. So when we did this for the AWS workshop, we had to change its name. So this is the Applying Chaos Engineering workshop for Kubernetes, which is the 50 Shades of Kubernetes. Or at least it was when I first wrote it, and then that got changed. So yeah, just to see that this is the sort of place where you can explore these sorts of automated chaos experiments. Sorry? Oh, I'll tweet the link out later, but also I can write it down for you.
Well, you know this is going to be on there.
Okay, so now we're going to look at the Chaos Toolkit. As I said, free open source tool. The reason we created it is because doing chaos engineering is quite tricky at the moment. There's a lot of tools out there. Most of the tools out there cause harm on systems. The problem is none of the tools that I've seen emphasize the learning loops. So we wanted one that did that. It's an open source project. There's plenty of documentation out there. You can actually go and join us on Slack if you're using Slack. Some people don't like it with a passion, so you don't have to. But if you want to, we can go on there and you can bother us. You can bother me. Actually, the best one to bother is Sylvain, my co-founder of the project. He's French. Bother him. He's a lovely guy. He's my best friend of about like 20 years. But yeah, bother him. And this is what it looks like. So you will use the Chaos Toolkit to cause chaos and to detect the conditions of the system through a bunch of drivers. And there are also some plugins to the Chaos Toolkit that will allow you to do some extra functionality to the CLI. That's it. The main smarts are in the drivers, how you cause chaos against different systems, and how you detect certain conditions for your steady state hypotheses. Those will come through the drivers. The Chaos Toolkit, really, all it's doing is orchestrating this chaos according to an experiment description that you've written. If you've used Terraform, it's a bit like Terraform for chaos engineering. Terraform is a way of orchestrating cloud resources using a common format and against multiple clouds. Well, this does multiple versions of Chaos according to a description that you give it. It's just a CLI because we're big fans of keeping things basic. We've written it in Python. We are unapologetic. We love Python. Okay, so don't worry about the fact it has a library in there. That just has to be there for completeness. But the main thing is we have drivers, and drivers come in several forms. You could write a driver in Python, most of them are, or you could just have a process. So say you've got a little tool of your own that causes some set of conditions, you could use that. You can plug that directly in. Or you can even instigate an HTTP endpoint. You also have a bunch of plugins, and I'll explain one plugin in a minute and why it's a plugin. See that animation? That is why engineers shouldn't do graphic design. I made that animation, and it bothers me every time I see that slide. I will eventually take it off. Okay, so in terms of where you find this stuff, it's on GitHub under Chaos Toolkit. That's the main mature set of projects. There's also the incubator. The incubator is for stuff that is not quite so mature. What you will find in there is everything from really works well and is almost complete to I woke up this morning with a funky idea and I haven't done anything more than create a repo for it. So just to warn you, there's some stuff in there that's moving, but there is some stuff in it that's very mature as well. So things like Chaos Toolkit Prometheus. Prometheus, if you're not familiar with it, is kind of an observability system for your system. So why would it be under chaos engineering? Well, it's there because we can have probes in our experiment that use it. So although we don't cause chaos through Prometheus, it is a mechanism for us to be able to probe, and we need probes for our steady state hypothesis. So this is what it looks like to drive the Chaos Toolkit. You give it a description of your experiment. It's in JSON. I apologize for this. The reason I apologize is I never thought it was a problem to use a JSON description for a chaos experiment until I met a lady in Oslo who came up to me very honestly and said, I will never use your toolkit. And I was like, fair enough. Is it personal? No. She said, I am Danish. I have a German keyboard. I can never find the curly brackets. So she never writes JSON. Fair play. We are actually working, there is an issue out now for a YAML version, which I will never use because YAML just gives me problems.
They don't have curly braces on German keyboards?
They have them, but because she's used to a Danish keyboard, and where it is on the German keyboard is weird. It is properly weird, and it seems to move. But anyway, that's what she showed me it. She actually hit, depending on the actual mode she was in, the thing was in the wrong place. It was very bad. It was a bad weld. Just pointing out.
How do they write code?
Don't get me started. She writes a lot of YAML. That's what I'm saying.
I work on English systems. You know.
Oh, we have problems.
System over in England. I can never find the backshift key.
Yeah.
You've had that same issue.
Yeah, the other way around.
The back.
And you have this funny currency symbol instead of a pound sign. I don't know. Okay.
That one I have programmed in.
Okay, so we have this is just a declaration of our experiment. It says what the steady state hypothesis is, and it says what we're going to do to cause harm on the system. And we give it to the CLI, and what it does is then orchestrate our chaos using different drivers. Look at that. So how do we build an experiment with it? I love these animations. They're so good, aren't they? They're not distracting at all. Okay, so the first thing...
was a human order.
This is a Nautilus. Right, so a little story here. When we first created the toolkit, we used a monkey. Not the monkey from my first book. So I've written 3 books. My first book has singly the worst animal on the front cover of any book of all time. It's called the Aspect J Cookbook, and the animal on the front looks like it hates the reader. It actually looks like you've interrupted it in a moment of its own. I can only assume it was holding a branch in a previous life. But right now, it either looks like it's threatening the reader or it's just finished something. Anyway. So we had a monkey down there, which I've always found dangerous in my career. Monkeys are dangerous. And then I spoke to Casey in Netflix at the time. And I said, look, we've done the toolkit. We talked about this, and we got the monkey. He said, no, we're not doing simians anymore. The simians are gone, man. It's now something else. We're not doing simians. I was like, no. And then the next best thing we could find was a nautilus, which everyone confuses. So anyway, but why did we pick it? Because we couldn't pick a monkey.
At least it's not a slug.
It's not a slug. It's nothing too gross. I'm not entirely sure where its face is, but yeah, it's there. Plus, I'm a big Captain Nemo fan, so Nautilus was kind of cool for that. Anyway, so the way you work the Chaos Toolkit, you discover, that's the first thing you do. You point at the system and go, see what you can find. Not in terms of weaknesses, but what is there. It's kind of like snapshotting your system. We thought about this command being snapshot originally, but discover is more meaningful. It returns a document that detects what you've got as best it can. It also detects what you might want to do against that system, because then you use the init command. The init command is initializing a new experiment. It takes what you've discovered and builds you an experiment. And if you're lucky, you don't ever have to touch the JSON. Once you've got your experiment, you run it against the system, it returns some results, and then if you want to make those results readable by other human beings, then you can use the report command, which is a plugin to the toolkit. The reason report is a plugin is because it produces PDFs and HTML and other stuff. And all of that requires some baggage. So we didn't want to bake it into the toolkit itself. But most people want to use it. Right, Chaos. I love the fact we have the Chaos command. I was very proud of that. Just typing in Chaos every time is great. Okay, so Chaos, discover, Chaos Tool Kubernetes. This will go and look at your Kubernetes cluster and come back with all sorts of information about it, including some of the things you might want to do in terms of hurting it and probing it. It will produce this discovery.json, which you can go and look at if you like JSON. But I personally wouldn't go and read it. It's there, but it's there really to feed then into Chaos Init. Chaos Init takes what you've discovered and runs you through a workflow to produce an experiment, which you can then check in. It's just a JSON document, you can share it with others. One of the things that's really surprised us is the DevSecOps community are really keen on the Chaos Toolkit because they can actually share their experiments amongst each other. You can see what people are doing and why you might want to do it as well. Then you run your experiment with Chaos Run. And this is where we need to improve the Chaos Toolkit, because for me, every time I see a slide, it makes me annoyed. Because it's reported failure in the experiment. It's not failed. It's brilliantly successful. It's found a weakness. I wanted that. But anyway, it's coming back with failed, but what's actually happened is it's detected one of the steady state hypothesis probes is outside of tolerance after we did our experiment. Now, Chaos is extremely collaborative. I mentioned earlier it should never be a surprise. Chances are you have other people that want to read stuff about it or know what you've just done. So, we built the report command in there I mentioned earlier. Report takes the output from your experiment and gives you a wonderfully professional looking scientific report. This is what you send to the managers and go, look, we have been working hard.
Handy for London Bank.
Absolutely. Please.
Do you have charts and graphs?
Not yet, but we have a group that are looking to do it.
We need charts and graphs to actually give it to management because you know they don't read.
We've got a bunch of this tree.
Needs to be
there is an exec summary in there, but there is a summary, but it's not got enough pictures. You're right. We actually have. Well, I did this talk. Where the heck was it? This tour has been so long. I did this talk somewhere, and a lady there said, I'm going to write a new version of report that gives you the format with graphs that proper scientists would want to see. I was like, fine. So she started working in the community to do that. It's great.
Managers can't read proper science anymore.
No, we need something really toy there.
They don't understand.
It's got an abstract for them. That's probably as far as we expect them to get.
They understand the average. They don't understand standard deviation.
No. True enough. Okay, so to run report, you just tell it what export format you want, give it the journal of the output of the Chaos Run experiment, and then you get your report PDF out. Okay, so in summary, I have a confession. I lied to you earlier. My name is not... No. I lied to you earlier. I lied to you when I said there are no best practices in complex and chaotic environments. I should have said, until very recently, I hadn't got any good or best practices in those environments. I've taught microservices now for many years, and I teach cloud native and other systems as well. But with chaos engineering, I can honestly say it's the first time where there is a just do it best practice. Even if all you do is a game day, even if all you do is explore one weakness in your socio-technical system, it's worth it. The best time to do it, just before a retrospective. Anyone here, hands up if you do retrospectives in your current workplace. Okay, so retrospectives, I used to hate retrospectives because they always went like this. They would say, right, what are we good at? What do we want to do more of? And what do we want to do less of? And you'd sit there and go, again? Every week, 2 weeks, whatever it was, that's the thought, because it's really uninventive. But it's a good thing to do, but it became almost a whinging shop. Okay, if you do a game day just before a retrospective, you will have such emotion in the room. Nothing beats or makes a retrospective kick butt like developers and ops walking in tears. I mean, not proper, that makes me sound like a proper sadist, but the point is, they are ready to learn then. They're ready to improve when you've been through the pain. This is something I was taught when I wrote my third book. I wrote Headfirst Software Development, and I was taught by Kathy Sierra how to write those books. And one of the things she taught us is that the brain doesn't care. The brain has a crap filter. Okay, the mind, the conscious bit, the thing that right now is saying to you, Russ is going to say something interesting in a minute, I hope, that's your mind. But your brain is sitting there going, I don't care. The brain only cares about 2 or 3 things. Number one, it cares about whether you're going to eat.
Breathing.
Actually, it just keeps that going, hopefully. But yeah, it cares about that too. Breathing is important. So it cares about whether you're going to eat, whether you're going to be eaten, or whether you're going to procreate. These are difficult things to bring into a teaching session. Not impossible, difficult. Yeah. That's why people do. I think there's an element of that. Problem is, that's why straight after lunch, not only are you facing the fact that everyone's body drops down, but also the brain is going, I'm satisfied. I don't care what anyone says now. Right, okay. So the relationship here is, you need people to feel danger in order to learn something. And when we're writing the Headfirst books, that's what we used to do. We would try to make you feel the pain of what's going on. That's why they make you do things in those books, because they want you in the story. Now, if you've made the pain immediate and unignorable just before the retrospective, the learning is so much better for those reasons, because the brain is engaged. It's the brain that learns, not the mind, unfortunately. Okay. So chaos engineering, for me, is a best practice. Just do it. I don't care how you do it, but just do some form of it. Get into it a little bit. Game days are the easiest place to get started, the cheapest way to get started. All you need to do is get some people together and go, what happens, what are we worried about? What happens when that happens? Once you've got a few of those game days running along and you start to think, well, we could probably automate these to build confidence consistently amongst these things, then I would recommend using the Chaos Toolkit. The Chaos Toolkit's mission is to have as many drivers as we can possibly get so you can run Chaos against whatever systems you've got, and you can always extend it in your own ways. One interesting thing, a validation of this approach that's come out, is that the Chaos Toolkit is now being used by people we're surprised by. One group started using it. It's a little company called Microsoft. They've started using the Chaos Toolkit to drive their new Chaos API. So yeah, all that stuff is coming online and something that you can tap into using the toolkit. Okay, next steps for you, read the Principles of Chaos. My good friend Casey wrote, with a bunch of others, these principles down. They're well worth reading. There's also a free Chaos Engineering book. If you haven't got it, why not? It's free. You have to give up your email address. Create an email address, then get it for free. If you're not worried about them sending you emails or something. It's a great book, and it introduces the subject. And I just want to talk about the future, just for a moment. Now, the future's dangerous. You know, most of people's predictions are completely wrong.
Well, at least in notion the future is.
But I want to tell you something. I've seen the future. No, I want to talk about the future briefly, because I have seen where things are going. Right now, everyone's creating systems that hurt systems. Loads of tools out there for hurting systems. In the future, platforms will incorporate these things. I know that on good authority because I know Amazon are looking to do it. Microsoft have beaten us all by putting it in. The others will do it too. Now why? Ask yourself this. Why would you as a platform provider introduce an API that allows people to break parts of your system? Because you can show how your system is better at recovering from these things than others. You can allow your customers to get that trust and confidence that we talked about in the beginning. It's a differentiator. That is my only little tidbit for what's happening down the line. Just to make things confusing, that's what the environment of chaos engineering looks like at the moment. There's loads of people in it. There's a diagram, I'll give you the link on Twitter to this if you're interested in who the players are and what's going on. The truth is, there are so many more companies that are shown here doing chaos engineering. So many. You can see it now. If you want to find out who's doing it, search for jobs. There's now dozens of job postings for chaos engineers from all sorts of companies. I know because they asked me to join them. Okay, I though am this lot. This is my company. So if you do want to start playing with chaos engineering, give me a shout. I'm very good as a consultant in the sense that I don't immediately give you an invoice. Do you know what was it the collective noun for a group of consultants is? An invoice. But the idea is, if I can answer the question quickly, I will just do it. So get in touch with me if you're starting to do these things, and I will answer your questions. If you turn around and ask me something that is a bit more extended than a quick answer, I will say, look, maybe you need to engage me to do this. But most of the time, it's a quick answer, and I'm happy to do it. Best way to get hold of me? Twitter. DM me. Or just message me if you can't DM me, message me, and we'll then get a DM going. The reason I don't suggest you email me, at any moment in time, I have about 120,000 unread emails in my inbox. I do not subscribe to Inbox Zero. Now, I see this as a chaos experiment against Google. Which is a bit of a lie. I'm also lazy. So you can send me an email, I might get it, but as I say, there is a small chance. I treat it like Twitter. I'm a natural Twitter person. I just treat these emails going past, going, oh, that's interesting. So yeah, send me an email if you want, but there's an outside chance. The other place to get hold of me, if you want to, is connect up with me on LinkedIn. Okay, I'm good on LinkedIn. It tends to be a low noise environment for me. So if you want to ask questions, that's another great way of getting hold of me. And with that, it is not Geek 10, it's that Geek Tour 20. You want that one because that's 20% off. Thank you very much for your time, Steve. Are there any immediate questions? Wow. Okay, hang on. 1 second. Right, I'm going to navigate. I'm going to go from the right-hand side, if it's okay. Just right there first. Please.
So, is there any distinction between taking a monolith web API, breaking it down into microlists? Would you consider that microservices, or is there a distinction between that and then moving to the next?
Excellent question.
Repeat the question.
So yeah, we'll do. So is there any difference between starting with microservices, I guess would be one way of doing it, or the alternative which you mentioned is going a monolith and breaking out micro lists, I think you call from it. When I teach the microservices course, the very first thing I point out is that I don't care how big your microservices are. That's why I don't like the term. I only care what you can do with your system that you couldn't do before. So if your system is decomposed into 5 parts, for the sake of argument, and those 5 parts evolve separately, and that speeds up your velocity for features, you win. That's the rule. We do microservices because it follows the breakdown of teams, potentially, which is why Netflix did it. And it also gives us that increased feature velocity. That was its point. Feature velocity was the only reason to do it. So whatever you do, whether you do a monolith or break it up into smaller parts, whatever big they are, feature velocity is the measurement of improvement there. So that's why when I teach the course, I talk all about what parts do we need to bring together so they evolve together. What are the things where the friction is going to be caused? I never go into how big are your services, because that's not important to me. Okay. Thank you. Please. Next question. I'm going to work across there. Please, sir.
How does this integrate with cybersecurity? I can see if I was a bad guy, what I'd like to learn from Russ so that I can cause the most damage, or as a company, what cybersecurity threats do we think would cause us the most harm that we need to protect against, and that should be part of our game day.
Excellent question. So let me just repeat that for the audio here. So how does this relate to cybersecurity is probably the summary of that. And you gave 2 circumstances. You gave how does it relate to the bad guys, and how does it relate to the good guys. Okay. So we'll start with the good guys first. The good guys are an interesting group because they've already come to me several times and said, we can see chaos engineering being sort of what we do already, but now we've got a formalized discipline for doing it. Plus we now have tooling that allows us to automate it in a general sense. So they really like it for that reason. At first, they were a little worried by this idea of exposing APIs that allow people to do these things. But then they realized that the whole point of those APIs is to prove and have confidence in your system. So actually, exposing APIs like this is a way of showing we can handle this. So that was a good thing. I'm actually doing a collection of workshops at the Open Security Summit in the UK on just this. How to use Chaos Toolkit to create secure DevSecOps, security-related chaos, and then be able to share. The thing is, it's all collaborative. You could share the experiment amongst the teams, and share it between companies. Because what you're seeing now is the security groups working together amongst consortiums of companies. Because why would you hide from one another? You're not attacking one another, so why wouldn't you work together on these things? And this gives them a concrete mechanism to share. Here's our experiments, this is what we do. The other side of it is that eventually they may share their drivers too. So they'll implement their own security drivers, we're already seeing that beginning to happen, and they may share those between companies as well. So for me, it's a platform as well as a discipline that actually fits beautifully into what we're calling DevSecOps now. So that's the good guys. You mentioned the bad guys. I'm not aware of any that have actually contacted me yet, but then why would I be aware? There is an element of you could use these things to just cause harm, but they're not out of the box hacks like that. I mean, you can use any language or any framework to cause problems. There's nothing special about chaos causing systems. The only thing that you could argue is that if you open an API that allows people to do this and you don't think that through properly, then you may be giving people a backdoor to cause problems for everybody. There is also another argument here. So when I talk to the banks, one of the things they don't like is other systems being able to cause chaos against them. So when we were building the toolkit, we had a few banks that were using it, and their main requirement was, we need to run this. I don't want you running this. Which we understood, and they still do, and it's still the way it works. There are a lot of other chaos systems out there, Gremlin's one of them, that specifically is a software as a service, and it's going to cause chaos on your system. It's going to do it in a very secure way, but even if that's arguably secure, some of those banks, for example, would resist that as a mode of work. So I can see the argument for it, but yeah, again, over time, I think this is going to mature to the point where the platforms do it anyway. You know, if you use Amazon, you know, they'll say to you, if we're running this chaos against these systems all the time, so you don't have to worry about it. The trust, I think of it as what's going to happen eventually, I think, is we're going to get better status pages. There'll be status pages, instead of just green lights, they'll be like, here's the chaos we're running to, and this is when we run it, and how frequently. So yeah, I can see that too. But in terms of increased exposure for bad guys and things they can do, I don't think we've increased it. I don't think they still will try and do the things they're trying to do. But I don't think we've given them any extra hooks at the moment. Thank you. Please. Yes, sir.
Do you ever see chaos and AI coming together?
Yeah, I'm assuming you mean chaos engineering, not just chaos theory. But yeah, because then we are back to Jurassic Park and everything that goes on there. Yeah, do I see? Yes, is a short answer. Two ways. So we already have a few rudimentary experiments that we run against deep learning algorithms, which means that we can show what happens when things break inside the algorithms, that you get incorrect answers, incorrect decisions made by these systems. So there is a degree of trust in those systems. In fact, arguably, in order to trust the answers that come from those systems, a chaos-related approach is probably important. So there's that angle. That's in its infancy, but people are starting to think about that. The other angle that we've looked at is, could we use the outcomes of experiments across everyone that's using chaos engineering and chaos toolkit? Could we come up with better suggestions for how people might want to improve systems? Don't we have potentially a platform for learning across all systems what is better for everybody? That's something we're looking at, but that's something we call Chaos IQ. So that's a separate system. It builds on top of the Chaos Toolkit. It's in alpha. You can sign up to it. And the way it works at the moment is when you run your chaos, your experiment, it will take your chaos experiment and it will take the outcome. It will also do anonymized comparisons with other chaos experiments and other outcomes that it's seen, and it will make suggestions for how if it sees a weakness, it will suggest how you might want to overcome it. And if it sees a certain form of system and this looks familiar to it, it might even suggest further experiments. It's predicting potential failures at that point. It's saying, look for this. Now, again, it's in its early days. And at the moment, I think we've got like 10 people using this. So we haven't got a huge data set. But the answers are starting to come. And so we're happy with that. So that's another angle on it. That's something that I'm excited about. The fact that we now have a formalized approach to building experiments and traversing their results means that we can take those two things and learn from them as an industry, perhaps. That's what I like.
Getting some consistent patterns for those kind of failures to more management on the
How do you mean? Can you give me an example on that?
Like
Sorry?
when you have applications where when you have infrastructure where those failures are something that could happen on a frequent basis,
Yep.
not just for one organization, but across organizations.
Yeah, so one of the things that we've noticed is that most people are at a level of doing small blast radius experiments at the moment. And so some of the things that Chaos IQ does is it tells you to run a larger blast radius against certain things if it sees it. So for example, some people look at killing a pod in Kubernetes. And we'll ask them to look at not just killing the pod, maybe kill the service, so that all those pods are unreachable. And that sort of thing, because we see other companies gaining advantages from that. So sometimes we're making that sort of suggestion. But that's still on its infancy at the moment. Some of it we're just noticing ourselves. But the idea is to automate that using, I don't want to get too fancy with it being deep learning or ML, but it's something that will do the rationale behind that. Okay, thank you. Please.
When you're talking about game day experiments, are we talking about live production systems? I mean, I got a live production system that, in a sense, generates $2 million an hour in transactions, and I'm cocking around with that.
It's an excellent question. Okay, so I'll summarize it, I think, just correct me if I get it wrong. So, do I have to do this in production when production is so critical?
Yes.
Okay. Most of my customers are not doing chaos in production.
Okay, I
was getting that impression. I'm glad you asked the question.
Now the reason that if you read the most of the blog articles and the book even, and even if you talk to me about it, I will say ideally
Yeah.
You run Chaos, Game Day or whatever in production. There's a reason for that, is that's where the most leverage is. That's where the reality is.
Yeah.
That's where the best learning is. But most are not there yet. It's a question of maturity. Once the systems get sufficiently mature, once your experiments get sufficiently mature, then you might consider running ones that you really don't think are going to cause a problem in production. But there's usually a path that people go through. They start by doing these things in something like staging or a dedicated environment, and then as these things get more concrete, they believe that the system can handle it, then they might consider running it in a very small part of production.
Well, I was going to ask that as a follow-up. I was going to ask that same thing. Why, in this day of cheap virtual, hardware and rentable hardware, why wouldn't you do this, on a staging system?
It's
easily duplicatable systems too.
It is. You say easier. In Netflix, for example, it's quite difficult to duplicate production and the conditions it's under. So that the point is, when you run these experiments, it's not just that you're running an exact copy even of what's in production. You're not running it
With 1 million people.
Yeah, and that's when the weakness might happen. So that's the difference. Is if you want the full confidence and trust, you get mature enough to do some of these things in production. But you can still build usually substantial confidence and trust in staging.
Can you design in initially the ability of a system to be running mirror, like getting the same data feeds, or at least starting to approximate real life, so
that's
you've got the plumbing to go, okay, I'm doing chaos testing, turn it on, give me my data flow,
Yes. So that's how chat, to some degree, that's how I think chat works in Netflix. It sets up a control group inside production and gets some traffic from it to whilst you're running the chaos experiment.
I'm still hanging out there. What's the difference between an experiment and game days?
Game days are more focused on the people involved and setting up conditions for a 3-hour exploration of, if this happens in this staging environment, how do we deal?
You mean knowledgeable people?
Sorry?
You mean knowledgeable people?
Knowledgeable,
people who understand
responsible
the system
people.
And how it could break and how it could be fixed.
Yes.
Needs to be fixed.
Yeah.
An experiment is something you just kind of do when you feel like it? Or?
A chaos experiment is usually automated. So it's an automated description of, we're going to do this, and it's going to detect against the system, technically, has anything deviated from these tolerances.
Not as formal.
Wouldn't you run one or more experiments for game day?
You could do. Yeah, you could say we're going to run these during, or you could just manually make those amendments yourself to the system. So the reason game days are such a cheap option is you can do them completely off the cuff. Whereas with an experiment, you're usually putting a lot of thought into what the steady state hypothesis is and how the deviations might go, so you can detect these things as you go along. I'll give you just to illustrate that point a little bit. I did a game day recently where I wanted to explore an interesting weakness in the system. The weakness was an individual. This person was a hero in the group. I noticed this, and so I said, right, we're doing a game day on Friday. That person is not in. They're on holiday. They are not connected to Slack. They are not on text. They're not here. Have you any idea how hard it is in this day and age to get someone completely disconnected from their system? It's very difficult, but I managed it. It was basically on threat of almost firing to get this person to do it. And I had the agreement from the management that this was the case. And then we had the production incident game day on the Friday. That person was not in, and we learnt just how critical that individual was. They were all using one password for all of the credentials, but only he knew which ones were which. There was more than that. I'm telling you, the amount of weaknesses were huge. And do you know what? Everyone came out of that going, we need to know this, we need to know this, we need a playbook for that, we need to automate this playbook. There was so much learned on it, on that basis. So that's why I'm so passionate about game days, is you don't even have to set up all the formality. By doing something like this, exploring something like this, you can get so much improvement in the system. Okay?
That used to before we had everybody connected on iPads and iPhones and everything else, we used to say everybody has to take a full week of vacation. First off, it ferrets out any kind of things like you just said, plus any kind of nefarious embezzlers.
It's the whole, was it Superman 3 side of it.
Because most systems are set up that, you know, you can cover for yourself in a week, but, you know, with a full week off, that's when the problems, you know.
I mean, that just the main point here is this is the weaknesses, right? These are weaknesses that chaos engineering helps us do. And let's be clear, chaos engineering isn't new. We've been doing something like it. We call it disaster recovery.
We've called it all sorts of things.
Yeah, but it's now given a label. It's now given an umbrella term. And the reason I like the chaos engineering label, despite the fact I hate the term, is that it can get a budget now. And we can consciously do it. We can deliberately practice it.
What is the percent? That was the question I had. What was the percentage of budget for a project that's going to chaos or
that varies
recovery?
dramatically.
Yeah.
It depends on how sensitive people are to it in the first place.
With Netflix, you know, they're destroyed if their systems don't work. So
well, most people are destroyed if their systems don't work. So they're one way of it of I can't give you a figure, but I can say to you the way I make people very sensitive to it. I ask them how much it will cost for the system not to work for a day, and I ask them how frequently that happens.
I can tell you, 10 years ago, we could recover with phones and ledgers and get our systems back
Can't
up.
now.
Yeah.
And this is the thing, right? So our systems are getting more complex. They're changing quicker than ever before because the business needs to compete. And at the same time, if they don't work, we lose millions quickly, and for some billions. So putting a number on how quickly can we deal with things when they go wrong is the way the budget for chaos engineering comes about.
I wasn't sure, can you during development build in, you know, the hooks or the whatever it is for subsequent chaos, you know, testing?
Yes, I mean you can see it in some choices. So some people use Istio as a service mesh, and that has chaos fault injection techniques. So that makes life easier for everybody. Some people are starting to build custom code where they offer endpoints that you can make a service slow down. But I think that will become, again, something that's a property of the platform. So that's where people are going to bake this in. It's not going to be something that you have to write frequently yourself in terms of allowing hooks. Eventually, you'll write your code as naively as before, and the system will try to react to the chaos that's happening. That it will be another layer of service that the platform can provide. Okay, thank you so much for hanging in there to the end. Cheers. And keep watching the tour and buy the book. Grab the book and then donate if you would like to.
Thank you for joining us for the April 2018 meeting of the Houston.net Users Group. Our next meeting will be on May 10th at the Improving Houston office at 10111 Richmond Avenue. If you happen to be in Houston then, or on any second Thursday, we'd love for you to join us.